For these sections, we will look at an example on how to solve the heat equations by using both explicit method and also implicit method, Nicolson. So the heat equations given and defined as this: ut equals to 2uxx, where the x from 0 until 5, t greater than 0. So with the boundary conditions given, two boundary conditions at the two endpoint and also an initial conditions. And now for the part A, delta x equals to 1, delta t equal to 0.1. Sketch a suitable diagram to show the grid point where the solutions are calculated and label all the initial solutions until t equals to 0.2. And for the B, find the solutions until t equals to 0.1 only using explicit finite difference method. And for the C, using Nicolson method to show the above problem can be written in this form. Later on, we will look at the proof in the sample solutions. And R here given as K over H squared. And for the D, we need to use the equations in the part C to write the solutions until t equals to 0.1 in the form of AU equals to B, and solve the system of linear equations by using Thomas' algorithm. Now we look at the solutions for the part A. For the part A, we need to draw this diagram, and from this diagram actually help us to know how many values we need to find from these solutions. And from here, ut equals to 2uxx, with the two boundary conditions, one initial conditions, we are able to find these all values. So for the two endpoints, the first endpoint we have the 1, 1, 0. And for the second one, we have the 4, 4, and 25. And for the initial conditions given, we're able to find all the values at this line. So we have the 0, 1, 4, 9, and 16, including 25. So we need to label all these values clearly, and also we need to label also what is the points that we need to find from these solutions. So the I and J, the points that we want to find is that U11, U21, U31, U41, and U12, U22, U32, and U42. And next, we will proceed to the part B. For part B, we are going to solve it by using explicit method. So we transform these heat equations into the finite difference approximations, and now we let the uij plus 1 lead the equations, where here we have the r equals to 2k over h squared, and we put in the values of k and h, we are able to obtain r equals to 0.2. So we put it into these equations, and finally we have this. So this is ready to be used in the iterations to get the approximations for each of the 8 values that we're interested to know. However, if you look at the questions B carefully, we just need to find the values until t equals to 0.1 only. Therefore, we will focus on these 4 values. So to find the U11, we substitute the values that we know based on the initial conditions, then we're able to obtain the U11. And U21 also, based on the initial conditions and the values that we obtained, we're able to find the U21, and next U31, U41. And for the part C, we will proceed to the Nicolsons. Before the solutions, we need to do the proving. So to do the proving, we can refer to this. So based on the Nicolson formula, we have the ut equal to this term and uxx equal to this term. Okay, including the 1 over 2. And here also 1 over 2. And multiply k for the both side, simplify it, and let the k equals to k over h squared. So we have the k 0.1, h equals to 1, so r equals to 0.1. Therefore, we are able to show the equations as given in the question just now. So basically, these 3 are the unknowns, and another 3 terms are known values. And from the equations that we obtain, we can proceed to the solution in part D. In part D, we can simply draw this diagram to show the locations for the iterations. So from the first iterations, we are able to form the first equations. Based on the boundary just now, okay, we are able to find the equations with the u11, u21 as two unknown, and then we have the right hand side values 1 over 1.3, and these coefficients is come from the simplifications of the equations. And then for the second equations, we can obtain based on this diagram as well. So we have the three unknowns here, which is u11, u21, and u31. Okay, we move it to another steps, and these are the values that we obtain from the boundary, from the initial point, from the initials. And then the next one, the third one, also the same, and we continue until we have obtained 4 equations. From these 4 equations, we have 4 unknowns. So this is a tri-diagonal system. We have the A, U equals to the B. So we need to solve it by using the Thomas algorithm as instructed in the questions. And now we look at the solutions from the Thomas algorithm. So from this table, we are able to find all the values that we want, which are u11, u21, u31, and u41 from the last row of the table. So these are the approximations of the values that we are interested to know.